Okay, this is Algebra 1, Section 7.7. I want you to think back, look at your notes from 7.3, and we're going to talk about those special quadratic equations. So the first one was the perfect trinomial square. And remember the way we look at that, the first and last terms are perfect squares. X squared is a perfect square, 9 is a perfect square. And the middle term is the square root of the first term, which is x, the square root of the last term, which is 3, and then doubled. So I know that this is a trinomial square. And the way you factor that, it's the square root of the first term plus the square root of the last term, and then the binomial is repeated. So in other words, it's the square root of the first term. Whatever that sign is goes right there. And then the square root of the last term, and you square the whole thing. So that's just repeating what I just said. So then the other special quadratic was the difference of two squares. Obviously, you're going to ask yourself, if there's only two terms and it's minus, you're going to ask yourself, is the first term a perfect square? In this case, it is. Is the last term a perfect square? 9 is a perfect square. So this is a difference of two squares. And the way you factor it, just like before, only this time it's the square root of the first term plus the square root of the last term. Factors are the same in the second binomial, but notice that the sign is different. And when you do that, remember that middle term is going to drop out. That's why there's only two terms. If the quadratic is a difference of two squares in that form a squared minus b squared, then you just take the square root of a plus the square root of b times the square root of a minus the square root of b. That's all there is in 7.7. I think I'm just going to go ahead and go right into 7.8, which is the last section. I think before you do the worksheet for 7.8, I'm going to have an extra assignment for you, and it's just going to be practicing all kinds of factoring. We might do it after this. I'm not sure. I'll decide when I get back from quarantine. So this one is called factoring by grouping, and you use this when there are 4 terms in the polynomial. So if you have 4 terms, you want to ask yourself, can I factor this by grouping? And I'll show you how to do that. So for example, let's say we want to factor this trinomial. Notice that there's 4 terms. And we want to group the terms into pairs. So I'm going to group the first 2 terms and then the second 2 terms. And I want you to look at, when you do that, I want you to look at, in each one of these groupings, is there a common factor that I can divide out of that group? In this case, x squared would be a common factor because it's something that both of these terms have. So if I take an x squared, if I divide this by x squared, what I have left in parentheses is x. If I divide this by x squared, what I have left is 3. And remember, whatever you're dividing out goes outside of the parentheses. So this is like we're doing backwards distributive property, if you can think of it like that. So in this one, notice that they're both even numbers, so I know that I can factor out a 2. When I factor out a 2, 2x divided by 2 is x, and 6 divided by 2 is 3. Now what I want you to notice, that what's left in parentheses is exactly the same. So now we're going to consider that the common factor. I'm going to rewrite this is the common factor, and then this is what's left over, x squared plus 2. And that's how you factor by grouping. Okay, let's look at this one. Sometimes you have to rewrite it so that you're regrouped a little bit. So I'm going to regroup so that I have these two together and then these two at the end. So rewriting, I have x squared plus x plus y plus x times y. I'm going to group those together. The common factor here is x. When I divide out an x, I have x plus 1 left over. Here the common factor is y, so I'm going to divide that out. And when I do that, y divided by y is 1. xy divided by y is x. Notice that these are the same. That now becomes our common factor. I'm going to write that down. And then the second parentheses is what's left, x plus y. All right. You're going to get a lot of these where it says factor completely. Obviously, this is not written in standard form. I want everything over on the left. So this would become 2x cubed plus 8x squared minus 10x equals 0. Remember, you want to get everything on one side, and then we're going to factor. So remember, the first thing you always look for, is there a common factor? There is. Every term has an x, and every term is even, so I know that I can factor out a 2x. When I do that, 2x cubed divided by 2x is x squared. 8x squared divided by 2x is 4x. And negative 10x divided by 2x is negative 5. Okay, well, you'd think you're done right now, right? You are not. Because I can factor this trinomial. Remember that 5 is a prime number. The only way it's going to factor is 1 times 5. So I just tried x minus 1 times x plus 5. Let's FOIL this and see if I get what I started with. X times x is x squared. The outside is 5x. The inside is negative 1x. That leaves 4x. And negative 1 times 5 is negative 5. So if I were solving this, remember when we have all these factors set equal to 0, either this is 0, or this is 0. And because I have 3 factors, I know that I'm going to have 3 answers. So the first one is going to be 2x equals 0, x minus 1 equals 0, and x plus 5 equals 0. And I'm going to solve each one of those little equations. In this case, x would be 0. In this case, x would be 1. And in this case, x is negative 5. And that's how I would write my answer. Here's another example. See if I can fit it in here. Okay, this is 4 terms. I am going to regroup because these 2 terms don't have anything in common, no common factors. So I'm going to put these 2 together and these 2 together, and let's see what we do. So this would be 2x cubed minus 18x plus 3x squared minus 27. And in this grouping, my common factor is 2x. And when I divide both of these by 2x, I get x squared minus 9. Common factor here would be 3. And if I divide both of these terms by 3, I get x squared minus 9. Notice now that I have a common factor here. So I have x squared minus 9 times what's left over, 2x plus 3. Except we're not done yet, because what is this? This is a difference of 2 squares, which I know factors to x plus 3 times x minus 3, and then just bring this down. And if I were solving this, if this were all set equal to 0 and it said to solve, then I would set 3 equations. X plus 3 equals 0, x minus 3 equals 0, and 2x plus 3 equals 0, and I would solve all 3 of those equations. So remember, whenever it says to factor completely, always look for something like this when you think you're done, because you're not really done. And that pretty much wraps up chapter 7.